Hi, I'm going to continue statistics today with you. We left it at looking at the mean, the mode, the median, the last recording. So in this recording we're going to move on and have a look at variability of data. So if you remember, the mean, the mode, the median are all measures of centre, in that they give you a feeling for what values lie around the centre of your data. When we talk about variability of data, we talk about the spread of data, or the difference between the largest and the smallest value of our data set. There's three of these I'm going to look at again as part of your course. The first one is the range, the second one is the standard deviation, and then we're going to look at the interquartile range. Okay. So if we have a look down here at the bottom, each of these sets of numbers has a mean of 4, but the spread of each set is different. So in other words, the first one is 4, 4, 4, 4 and 4. So obviously the mean of that is 4. If you add them all up, you'll get 20 divided by 5, which is 4. B, 1, 3, 3.5, 4.2, 8.3. It's telling me it has a mean of 4 also. Part C, minus 196, minus 49, 25, 66, 174. So again, a mean of 4. But what you'll notice about all three is that the spread of each is different. So in other words, if I look at A, there's no spread at all between those values. Okay, they're on top of each other. If I look at B, if I look at the top value 8.3, and if I look at the smallest value 1, the range of that data, or the max value minus the min value, is 7.3. So there's roughly 7 between the largest and the smallest value. However, if I look at C, I'm going from 196 up to 174. I'm just on my calculator here. So the range of that data is 370. Okay, so a huge range. So although the three data sets had a mean of 4, their spread was a whole lot different. Okay, so there's different ways of measuring it. So a little bit I'll talk about is why is there different ways, when do we use the different ways, so on and so forth. So the range is the one I've just talked about. It's based on the extreme values of the distribution. So the formula you need to know is that range is equal to max value minus min value. Okay, it is often used because it's quick and easy to calculate. A list of data with a small range tells us the data is more consistent than similar data with a bigger range. Okay, so often used because it's quick and easy to calculate. It gives us a feel for how spready our data is. In other words, if you were measuring the heights of people and you had a very small range, then you would conclude that the heights of that group of people were similar. However, if you're measuring heights and you got quite a large range, you would conclude that you had both small and tall people in that group. Okay, another measure of spread is, or variability, is what's called standard deviation. Okay, it's given a Greek letter called sigma. It's like an O with a hat on the top, and it is one of the most important and useful measures of spread. It gives a measure of the deviations from the mean, and it's calculating using all the values in the distribution. Okay, so the advantages of standard deviation is that every value is compared to the mean, and we use all values in the distribution to calculate standard deviation. If you compare that to range, we only take the max value and the min value. We don't even look at the ones in the middle. Okay, standard deviation is quite a long, cumbersome calculation. So I'm going to do one by hand for you. Okay, so the formula that I'm going to use, let me just not share for a minute until I show you the formula, is as such. Its standard deviation is given by sigma, which just means the sum of all the values minus the mean, that's mu, to be squared over the number of values, and then we get the square root of it. Okay, it is in your log tables, that formula, and it is on page 34. No, actually 33. It's on page 33. So in the middle you'll see a section, the top section is mean, you'll see just under it then standard deviation formula. Okay, so I'm going to do it on the values 1, 3, 3.5, 4.2 and 8.3. Okay, so let me just take down those values here on my pad, and we'll do it then. So they are 1, 3, 3.5, 4.2 and 8.3. Okay, and my formula for standard deviation is the square root of the sum of the values minus the mean squared over n. Okay, I'm going to share my pad with you here now, and let's work this out. Okay, so if I asked you the mean of these numbers, we know it's 4 from our previous work, but it would be 1 plus 3 plus 3.5 plus 4.2 plus 8.3 all divided by 5, and it is equal to, I'm just going to do it on the calculator even though I know the answer. So 4 plus 3.5 plus 4.2 plus 8.3 all divided by 5 values, so it's a mean of 4. Okay, so that's my mean. Now my standard deviation. Okay, which is often called SD, and it's the Greek letter sigma. Okay, it's like a 0 with a hat on the top. Okay, so to do this you tend to build a table. With your x values in them, then your mean, then you subtract them, then you square them, okay, so these are my x values here. So from the values it's 1, it's 3, it's 3.5, it's 4.2, and it's 8.3. Okay, so the first part of that formula I'm just reading over here is telling me x minus mu. Okay, so mu is your mean. We calculated that to be 4, so that's the same all the way down. So my next column then is x minus mu. Okay, so I'm just doing that inner part of that formula. So it's all of the x values, so it's 1 minus 4 to give me minus 3. This one is that x minus 4 to give me minus 1. It's 3.5 minus 4 to give me minus 0.5. This one will be 0.2, and this one is 8.3 is 4.3. Okay, the x minus mu. Okay, then if you go back to the formula, the next part is telling you to square it, and the reason you square it is to get rid of the minuses, because anytime you square a number it makes a plus. So this column here, this x minus mu column, is the differences. Is how much does each one of your values vary from the mean. Okay, so this x value here of 1 is a distance of minus 3 from the mean. This value here of 3 is a distance of minus 1 from the mean, and so on and so forth all the way down. We then square that those distances to get rid of the minus signs. So minus 3 squared will give me 9, minus 1 squared will give me 1, minus 0.5 squared will give me a quarter, 0.25, 0.2 squared will give me 0.04, and then 4.3 squared would give me 18.49. Okay, now I have x minus 3 up there, that should say x minus mu. Okay, so that is the distances or the differences or the variations squared. Okay, so we square it to get rid of the minuses, and then you see at the end we square root it because we've squared it to get back to it again. Okay, but before we do that, we're told to sum them all up. Okay, so now we need to get the sum of x minus mu squared. So that is literally all the ones in this column. So 9 plus 1 plus 0.25 plus 0.04 plus 18.49. So when I add all of them up, I'm getting 28.98. Okay, so the sum of all of the variations is 28.98. So that's that top line done. I then have to divide it by n. Okay, well, I should do that over here. And my n, how many numbers do I have? 1, 2, 3, 4, 5. I divide 28.98 by 5, and I get 5.796. Okay, and then the last job is the square root of it. So the square root of 5.796 is 2.407, so 2.41. So your standard deviation is 2.41. Okay, so what does that mean? That means on average, the distance from the points to the mean is 2.41. Okay, so that is standard deviation. That is a measure of spread. Okay, it's considered better because it takes each of the values, as you can see, and it compares them to the mean. So we took each of the values here, 1, 3, 3.5, 4.2 and 8.3, and every value became part of the calculation to get us the standard deviation. Okay, so quite a long-winded calculation, an important one to understand what it is. Now you can do this on your calculator, so I'm going to talk you through how to do this on your calculator. I'm using a Casio FX83 GT. Okay, I'm not using the one that came out this year, I'm using last year's one because that's what I think the majority of you have. So if you press mode setup up the top and then press number 2, you go into stat mode. Okay, and then number 1 up the top is one variable, so press that one and then put in your x values. So hit number 1 there, equals, and you can see you move down your table. I'm now at location 2, that's what that column on the left hand side means. So put in the number 3. I'm now at location 3, so 3.5, 4.2 goes in, and then 8.3. Okay, and then hit AC to clear it because that's all your values in. Okay, so my calculator now, I have a little stat written up the top and I have the number 0 beside it. You then go and access all the different statistical measures that you can do on that data. So to do that, if you look behind the number 1, the key number 1, you will see that there's a STAT button. So hit shift to access that and then stat, and then we're going into number 4. And in number 4, we have 1 being n, which is the number of numbers we have, 2 being x bar, which is your mean, 3 being standard deviation, that's sigma x, and then 4 being variance, which is not part of your course. So if I hit number 3 there, equals, you are coming out with a standard deviation of 2.399 or 2.4. Okay, now if we want to check our mean, hit shift, stat, again, hit number 4, and let's hit 2 this time, which is x bar, which is our mean. And we're getting 4. Okay. So in an exam question, it is perfectly okay to calculate your standard deviation in this way. You can do it using a calculator. Okay. You just have to know the steps as to how to put your calculator into stat mode and then access all of the statistical measures on it. It's slightly different on the newer calculators, the one that came out this year. If anybody needs help with that calculator, give me a shout. It's actually easier once you figure it out. But for now, I'll just stick with last year's calculator. Okay, let's go back to the book so and take a look at where we're at. Okay, where am I? Okay. Right. So that's standard deviation. You do need to practice it. I would suggest you do what question? Let's have a look. Let's do question 14 and 15. Okay, so 14 is fairly straightforward. I would suggest you do it once by hand, like I did building up the table, and then from there on in do it on a calculator. And then do question 15. For question 15 you'll have to do it twice, in that you'll have to calculate, you'll have to put machine X into the calculator first to get its standard deviation, and then you'll have to put machine B, its own table, in and get its standard deviation, so you can't do the both at the same time. So try them too. Let's see how you get on. Okay, I then want to talk about the empirical rule, which is written here. The empirical rule is an important part of your course. Exam questions do come up, and you have to know what it is. Okay, so I'm going to share my screen with you, and I'm going to just draw and explain the empirical rule as I go. Okay. You have a distribution, a widely known distribution called the normal distribution. Okay, so as part of your junior cert course, even as part of your leaving cert course, you are required to draw histograms. Okay, so as you know, and excuse my drawing, I might actually use something that will give me straight lines, or attempt to. Okay. Okay. So the histogram that you know and well, I could draw a normal distribution around it. Okay. So in other words, here on the y-axis, I have frequency. So in other words, if this was shoe sizes and this was for men, it was shoe size, 8 to 9, this was 10 to 11, this was 12 to 13, this was 6 to 7, and 3 to 4. Okay, and that was shoe sizes. Okay, you can see that the bulk of people's shoe size is between 8 and 9, then 10, 11, 6 and 7 is fairly popular as well. Okay, so the normal distribution is just a curve that is more or less drawn over that histogram that we would know well, and it is also called a bell curve. Okay, what you'll find with the normal distribution, the same with the histogram, is that your mean value will be the value in the middle. Okay, so the value that occurs most often, okay, will be the mean value in the middle. My histogram is atrocious, but anyway, the value in the middle is your mean. Okay, now where does standard deviation come into it? Well, standard deviation is a measure of variability. So for the remainder of the normal distribution, I split it up into chunks, into 6 chunks, 3 above the mean and then 3 below the mean. Okay, where the width of each of these chunks is supposed to be the same, and it's standard deviation. Okay, I put plus a standard deviation there because I've gone up a standard deviation from the mean. So the location of this spot here is mean mu plus a standard deviation. This one is mean plus 2 standard deviations because I've gone up 2 of them, and this one here is your mean mu plus 3 standard deviations because I've gone up yet another one. Okay, there's my mean mu in the middle. Okay, the location of this one here is mean minus a standard deviation. This one here is mean minus 2 standard deviations, and this one here is mean minus 3 standard deviations. Okay, so whatever value you got for your standard deviation, in our case it was 2.41, that means you take the mean value, whatever it is for your data, it was 4 in our case, and we're going up 2.41 every time. So for this example here that we did on the previous page, if I fill values into this normal distribution, I would have my, let me draw just a quick normal distribution for this data. Okay, that's my mean of 4 in the middle. If you remember, we calculated 4 for the mean. Okay, and then our standard deviation 2.41. So we're going up 2.41 every time. So that's 1, 2, 3. Okay, so if I add 2.41 onto 4, he's 6.41. If I add on another 2.41, he's 8.82. Get my calculator for the third one. 8.82 plus 2.41. So then I'm up at 11.23 for that one. Okay, in a similar way, I go down 3 standard deviations, so I break the lower half into 3 as well, and my values then down here is 4 minus 2.41, which is 1.59. minus 2.41. In theory, this is minus 0.82 and minus 2.41 again. And in theory, this location here is minus 3.23. So that is how you break a normal distribution up into 6 parts, 6 standard deviations. Okay, so what? Why do we do that? Well, this is where the empirical rule comes into it. The empirical rule, or the normal distribution, tells us the percentage of people that lies within certain bands. So in other words, to be able to draw a normal distribution in the first place, you have had to gather a large sample set. So you would have a large volume of data, and when you plot it, you will find that most natural occurring things in life fall within a normal distribution. So again, if we take shoe sizes, okay, what you'll find is that the bulk of men's shoe size will be somewhere around size 9. Okay, and then we'll have more here, more here, more here. Okay, so 9, 10, 11, 12, 8, 7, 6, and 5. Okay, and that's what you'll find when you gather enough data. So if you think about it, you have people with very large feet, but they are a small minority. You have people with small feet, but they are a small minority. The bulk of the people center around something between size 8 to size 10 or something in that order. Okay, so shoe sizes. Okay, if you didn't gather much data, you might have chosen a basketball team who happened to have large feet. So you might have people who had just mainly large shoe sizes. Okay, so you have to be careful that you gather enough data and it's unbiased. And if that's the case, you will find that in naturally occurring phenomena, it will follow that curve. Okay, the empirical rule then tells you that if you go from your mean and you go up 1 standard deviation and you go down 1 standard deviation, so in our case it was from shoe size 8 up to 10, 68% of the population goes between 1 and plus or minus 1 standard deviation. Okay, so here is my mean. I've gone down 1 standard deviation, I've gone up another one, so 68% of the world's population lies in that area. Okay, in a similar way, you will find that if you go out here, another standard deviation, so shoe size 7 to 11, you will find 95% of the population has shoe sizes between 7 and 11. Okay, now don't heed too much the actual shoe sizes. If your foot is bigger or smaller than that, it's not that you're abnormal, it's that I have made up data. Okay, so if I go to plus and minus 2 standard deviations, so 2 standard deviations down from the mean, that's the minus. 2 standard deviations up from the mean, that's the plus. You will find that 95% of the population lies in there. And then we go one more. Let's go 3 standard deviations. So in my example, it's shoe sizes 6 up to 12. You'll get 99.7%. And the remarkable thing about stats, about the empirical rule, is that those percentages never change. And you have to learn them off by heart because you could be asked a question on them. Okay, so you have to know plus or minus 1 standard deviation is 68%. You have to know plus or minus 2 standard deviations is 95%, and you have to know plus or minus 3 standard deviations then is 99.7%. Okay, and that is what's called the empirical rule. Okay, make a note of it, understand it, know these values here, know how to use them. Okay, and that's what's in that little box here about the CEO points. Have a read of the example, have a look at it, see what you think. And I'm going to do question 18 and 19 with you there. So question 18 says the masses of a group of students were found to be approximately normal with a mean of 62 kilograms and a standard deviation of 6 kilograms. So they've worked out standard deviation for us at this stage, and it says on the normal curve the arrows indicate intervals of 1 standard deviation. Okay. So all I'm doing is drawing in that. Okay, so it's calling this one here P in the center. It's calling this one up here 2 up Q, and 1 down R, 2 down, 3 down S. And we have to figure out what is P, what is Q, what is R, and what is S. Okay. Well, you have to know that P is always the mean in a normal distribution curve. So that's quite simply 62 kilograms. Okay, Q then is 2 standard deviations up. I'm just going to draw in my standard deviations here now. Okay, so let's fill in the values. So we're saying P is 62. Okay, so if my standard deviation is 6, it's like a step size. So this node here then is up 6 from it, so it's 68. Q then is up 6 more, so it's 74. And then this unknown spot here must be 74, up 6 more, it's 80. So Q then is 74 kgs. Or it's up 2 standard deviations. So it's up 12, 2 times 6. So add 12 on to 62 and you get 74. Or then is down 1 standard deviation. So take 6 away from 62 and you get 56. This unmarked spot here then is 6 less, so it's 50, and S then is 44. So R is down 1 standard deviation, so it's 62 minus 6, so it's 56 kgs. S is down 3 standard deviations, so it is 44, or the other way of doing it is 62 minus 3 times 6. Either way, you get 44 kgs. Okay, and that's question 18. So that's how you read a normal distribution curve with your standard deviations. Now, how do they ask the percentages? Well, let's look at question 19. Steel nails are produced so that their length is normally distributed with a mean mu equal to 4.25 centimeters. If 95% of their lengths are between 4.2075 centimeters and 4.2925 centimeters, what is the approximate standard deviation from the mean? So I'm drawing in my 6 standard deviations, it's always that. Okay, so my mean is 4.25. Okay, you have to know that 95% is the same as plus or minus 2 standard deviations. So in other words, it's between this node here, which is up 2 standard deviations, so that node there is 4.2925, and the lower one is 4.2075. Okay, it's plus or minus 2 standard deviations, so up 2 and down 2. Okay, or in other words, if I count my standard deviations, there's 1, there's 2, there's 3, there's 4. So there's 4 standard deviations between those two numbers. So therefore, if I subtract them, (4.2925) minus 4.2075, I am getting 0.085. I'm going to divide that by 4 because there's 4 standard deviations between them, so I'm getting 0.02125 centimeters of a standard deviation, which is quite small. Okay, does it look too small? No, it doesn't, and I'll tell you why. Because the 2's here are the same. Can you see that? Okay, so I'm down at the second decimal place here before I actually see a difference. So he's the same, he's the same. You can see the 4, the 4, the 2, the 2. So it's the 0 and the 9 which are different. Divide that by 4 and I roughly get 2 something. Okay, the other way you could have done it, in case anybody sees a different way of doing it, you could have looked at the difference between 4.25 and 4.2925, got the difference between them, and in that case though divided by 2, because there's only 2 standard deviations between those two numbers. Or in a similar way, you could have got the difference between these two numbers and again divided by 2. Okay, but you can see now you have to know the 68% is plus or minus 1 standard deviation, 95% is plus or minus 2 standard deviations, and 99.7% is plus or minus 3. Why is it 99.7 and not 100? Well, that's because there's tiny little areas out here which are normally the people who don't fit the normal distribution. So in other words, if it was heights, these would be the really, really small people, and these would be the really, really tall people. And not many of them exist in the world. That's why that 0.03% covers those two areas out there. Okay, so that's the empirical rule. Okay, so empirical rule. I'll find you a couple of exam questions too on all of this just when we get a bit more done. Okay, now the next thing I want to do with you, and I'll wrap it up after this topic, is the standard deviation of a frequency distribution. So we did frequency distributions in the last recording where you had in this case it was 50 boxes of matches. You counted the number of matches in a box and you saw the frequency or how many boxes had that number of matches. Okay, so I'm going to do this one with you. Okay, so this is number matches. And this is the frequency. Okay, so I have 47 48, 49, 50 and 51. 47, 48, 49, 50, 51. 6 boxes, 9 boxes, 18 boxes, 13 boxes and 4 boxes. Okay, so the question says find the mean number of matches per box. I'm just taking down the question here. And the standard deviation. Correct to 2 decimal places, so 2 decimal places. Do this question without using a calculator and using a calculator. Hence, estimate the number of match boxes that are within the range mu, so how many, between mu minus sigma to mu plus sigma. Comment on your reasoning. Okay. Okay, so the mean number of matches. So we add them all up and we divide by the number of numbers. Okay, but remember it's a frequency table, so I have 6 times 47, so I have 6 boxes with 47 matches in them, plus 9 boxes with 48 matches in them, plus 18 boxes with 49 matches in them, plus 13 boxes with 50 matches in them, plus 4 boxes with 51 matches in them. All divided by how many matches have I? 6 plus 9 plus 18 plus 13 plus 4. How many boxes of matches? Which I believe is 50. So 10, 19, 29, 37, 47, 50. Okay, and we put all that into a calculator. So 6 by 47 plus 9 by 48 plus 18 by 49 plus 13 by 50 plus 4 by 51 divided by 50. So my mean is equal to 49. Okay. So now with the calculator, how would I put that into my calculator? Well, you're already in stat mode, but if you weren't, you would go to mode setup and you would hit number 2. You then go to number 1, which is 1 variance. Now you can see when you do that you can enter in your x values, which in this case is always the first line, so it's the number of matches. But there's nowhere for me to enter in the frequency. So this is called a frequency distribution table. So I have to turn on this frequency option on my calculator. Right, so to do that, go Shift Mode Setup. And then you get numbers 1, 2, 3, 4, 5, 6, 7, 8. None of them is any good to you. Hit the down arrow and you'll see you've got 1, 2, 3, 4, 5, 6 here. And can you see that number 3 is stat again? So hit stat and you should get frequency question mark 1 on, 2 off. So hit the number 1 to turn on that frequency column. And now you should have the same table you had before with x on the left and frequency on the right. So now hit 47 for x and hit equals, and you can enter in all of your x values first if you want, because that's how your calculator defaults. So I'm going 47, 48, and you can see in the frequency column 1s goes in by default. That's okay, don't worry about them, we'll come back to them in a minute. And 51. So with your button, go right over to line number 1 across from the 47 and now put in 6. And if you hit equals to now, you'll see that it naturally goes down the frequency column now. So 6, 9, 18, 13 and 4. And that's all of the data in, and hit AC then just to clear it. And that's your data in. So now let's do some statistical analysis of it. So again, it's that stat button behind number 1, so Shift and the number 1 button. I'm still going into 4, and I've still got n, my number of numbers, x being my mean, 3 being my standard deviations, and 4 being your variance. I'm going to hit 2 for mean and hit equals, and you can see that we get 49, which is what we got when we calculated it. Okay, so all's good. So hit shift, that number 1 button again, stat, back into number 4, and this time I'm going for 3, my standard deviation, and hit equals, and you should get your standard deviation in this case to be equal to 2 decimal places. This is what the question asked for, so 1.11. Okay, so that's mean done and that's standard deviation done, and of course you can do standard deviation by hand if you so wish. It's there in the book, just pause it. I'll be on that page again when I stop sharing. Pause it, try it. It's a little bit different with a frequency table in that you have to multiply the 6 by the 47s. You'll see that, and I'll draw your attention to it in a minute. But for now, I want to do this part of the question here. Roughly decide how many boxes of matches is going from mu minus sigma up to mu plus sigma. Okay? So in other words, if I draw my normal distribution curve, I can now put 49 there at the center because we've calculated our mean to be 49. Okay, I can break this into 3. Okay, I can fill in my values. So 49 plus 1.11 brings me up here to 50.11, and if I add on 1.11 again, I'm at 51.22, and then this one to be 53.33. Okay, and if I go down from 49, so it's 49 minus 1.11, he's 47.89. If I minus 1.11 again, 46.78, and minus 1.11 again, 45.67. Okay, so this is mu plus 1 sigma, and this one here is mu minus sigma. This one here is mu minus 2 sigma. This one here, mu minus 3 sigma, mu plus 3 sigma, mu plus 2 sigma. Okay, but this is looking between u minus 1 sigma and u plus 2 sigma. So it's this area here. They're wondering how many boxes of matches are between 47.89 and 50.11. Now it's kind of hard to tell because of the decimal points, right? So if it was between 48 and 50, it would be really easy to tell. I'm up here at the table now because I would just add 9 and 18 and 13. But because of the decimal points, the 47.89, it's kind of hard to tell from the table. So the only way you have of really doing it is to know that mu plus or minus 1 sigma is 68% of the population, and we have 50 boxes of matches. Therefore we get 68% of 50 boxes of matches. So 50 divided by 100 multiplied by 68 will get me 68% of it. So it's 34 boxes of matches. Okay, and this is using the empirical rule, which is your justification. Okay, so yet another way where they ask the empirical rule. Okay, I'm going to leave this here because this is the solution for your standard deviation. Okay. Okay, your mean is 49. You filled in your frequencies, but this is your x minus your mu, so it's slightly different. You got the differences, and there's an extra f here for standard deviation of a frequency table. You'll see it here. It's also in your log tables on page 33. Okay, it's just the frequency part. So what's happening here is they're multiplying that 6 by the difference 4. So you have 6 boxes with a difference of 4 to give you 24. In this case you have 9 boxes of matches with a difference of 1, so that's 9. You've 18 boxes with the difference of 0, so that's 0, and so on and so forth. Add them up and divide by 50 again. Okay, so pause the video on that, work your way through it, see how you get on. Okay, and then try one. How about question 7? Okay, and I'm going to leave the video at that, and then I'm going to do some graphs in the next video. Take care.